Now I want to discuss a couple different broad categories of cryptography to introduce the particular system that we're going to talk about next. So a shift cipher is an example of a private key cryptography system. What does this mean? This means that the same key is what allows you to encrypt and decrypt messages. So you have to keep it secret, essentially. So with a private key system, you can only communicate with someone else using this code if they know the secret as well. The alternative, so sometimes, let me say, as opposed to public key cryptography, which uses different keys. So if you have different keys that you use to encrypt a message and decrypt a message, well, the decryption key needs to stay private, but the encryption key can be made public. And what this means, what this allows, is that anyone can send you secret messages that only you can read. So there doesn't have to be, you don't need to have a shared secret with someone else in order to use the system, which is very useful because, starting with a shared secret is quite hard. Or I should say there are ways to do that. But this is one way, for example, that you don't need to do that. And I think that's one of the applications of public key cryptography is to exchange a shared secret so that you can start doing private key cryptography. Because I think, private key cryptography can be a little bit cheaper computationally. So maybe you prefer to use that, but you use public key to get yourself started. So this is very useful to have the possibility of anyone sending you an encrypted message that only you can read. So how is this possible? I mean, the example of a shift cipher that we just saw, this is a private key system. And you can see that obviously, if someone knows how to decrypt a message, if someone knows how to encrypt a message, then they can clearly see how to decrypt the same message, or any message. So how is it possible that someone knows how to encrypt things, but does not know how to decrypt things? So we'll see an example in a moment, so you will see how it works in that case. But basically, let me tell you vaguely, it relies on something called a one-way function. Which I think is just vaguely used to refer to a process that is easy to do, but difficult to undo. So the example that's going to be used in our example in just a moment is that multiplying numbers is quite easy, but factoring numbers is hard. So just to give some concrete numbers on this, suppose we have P and Q primes with about 300 digits. I think according to the textbook, this is kind of the scale that you would use for these cryptography systems. Then, finding the product of these two numbers, well, with the current technology that we have available, this would probably take a fraction of a second. Not, no time at all. So multiply numbers, very easy. Machines can do it super fast. But the other direction is very hard. So if we're given n, which is about a 600-digit number, it is basically impossible to factor with the current technology. So this would take, on the order of a billion years. And this is how these public key systems are possible, is that you can publish the number n and you will have no fear that people will find P and Q. So you can rest assured that no one knows the factors. These will remain secret to you. So it turns out that this can be used for the basis of a public key cryptography system, which is what we will talk about next.